Hi, thank you all for joining us today. We're really thrilled to have the opportunity to share with you our recent work integrating Jupyter Notebooks into our Civis Analytics data science platform. This is me, and that's Saranga. My name is Lori Eich. I'm a senior product manager at Civis Analytics. I'm going to talk about our motivations behind our notebooks integration and how the need for collaboration became a really real problem for us, as well as our process towards finding the most appropriate solution.
Hi, my name is Saranga Komanduri. I'm a tech lead at Civis Analytics, and I'm going to talk about our engineering process going from scoping the feature to building it and getting feedback from users. And I'm also going to use a really bad analogy later in my talk, so keep an ear out for that.
So this is the Civis platform. Civis Analytics started as a data science consultancy based in Chicago, spun out of the 2012 Obama re-election campaign. And it's evolved into also being a data science product company. The Civis platform is the toolkit that we built for our own data science work, and it's now also available to our clients. We learned firsthand that spending a lot of time doing DevOps work to set up an environment is really not the best use of a data scientist's time. So we built this platform where data scientists can work the way they want to work, but backed by scalable Amazon Redshift cloud resources and in a high security environment. Our platform is essentially just software as a service with both browser and API support, so it facilitates easy collaboration on data science teams. Our users are typically solving data science problems for companies that want insights on their customers. Using our platform, they unify their customer lists with our data, build models to gain insights on their existing customers or to find new target customers, and to create reports about these insights. Data scientists can import data to Redshift, enhance their data with Civis data, interact with data using SQL, R, and Python, and run scripts in Docker containers, which allows them to connect to any code in a Git repository. Our users can also build automated workflows from scripts and publish their own apps and reports. Some users love working in the browser UI, while others use Civis platform entirely through the API with our Python and R API clients. We also make collaboration very easy with sharing and cloning. And all of the work done in our platform can be organized into projects. This makes it really easy to keep a set of imports, scripts, matching jobs, models, reports, all together in one place, and then you can just share that collection of work with your teammates. So now I'm going to shift gears a little bit and tell you a story about some work we did last year. We were presented with a pretty challenging client problem. We were on an extremely tight deadline, and the data we had to work with was noisy, chaotic, and really disorganized. There was a team of 5 Civis data scientists, and they dove headfirst into this project and started tackling different pieces of the solution. So these data scientists all preferred doing their exploratory analysis in Python. So they were all using Jupyter Notebooks. They were using these on their laptops so they could iterate and build out their work. However, when it came time to reconvene and put this project back together, they hit a huge wall. Their notebooks environments were all different. Their notebooks were all looking at different pieces of the data that they had to pull onto their local machines. They couldn't really interact with the original data source in Redshift, and it was really difficult to keep everybody's work in sync. The inherently independent nature of working in a Jupyter notebook was blocking them from successfully collaborating on this project. The team did end up delivering an on-time solution, but it required a lot of late nights and a lot of unnecessary stress and headaches, and we came out of this project knowing that we really needed a better solution. So as our product management team researched this problem deeper, we surfaced more things about notebooks that were problematic for data scientists. So as we already learned, collaboration is extremely difficult. You have to be working from the same environment, with the same libraries installed and pointing at the same data sets. At Civis, our data is stored in Amazon Redshift, so notebooks users would have to pull data from the cloud onto their local machines. And another problem we saw was that these notebooks were limited to the compute power of our company laptops. If somebody wanted to do something particularly complex with their data, they'd have to keep their laptop active and churning throughout the entire process. Well, yes, you can just build out your own notebook server environment to avoid this problem. It's really a tedious workaround that you shouldn't have to do as a data scientist. To our team, it seemed like the workarounds to enable collaboration and scalability were the biggest pain points for notebooks users. They were really just logistic barriers keeping them from the meat of this actual data science work. So we knew that our data science platform already provided the shared workspace that was so often needed by these teams of data scientists. So maybe if we added a notebooks tool, we could maybe give our users an iterative, exploratory environment that uses a variety of different languages and also alleviate their existing notebooks pain points. So in the end, we decided that the problem that we were trying to solve How might we include a notebook product in our data science platform? So this is really vague. This question is pretty open-ended, and there's a lot of different avenues we could take to solve it. Jupyter notebooks are really popular, but there's also other notebook products. Or we could build something on our own that just fits this iterative and exploratory environment requirement that we have. But the main thing we had to make sure was that any solution we ended up taking really takes advantage of these collaboration tools that we already have inside of our data science platform. So to help us figure out the best solution, we decided to conduct a design sprint. Design sprints are awesome. This is a product research technique popularized by Google Ventures. What happens is a small team spends 4 or 5 days together working on a really focused problem. In our case, it was how might a notebook product fit into our data science platform. They work through ideas, they make decisions, and eventually they build a prototype. On the final day of the design sprint, a prototype is tested with users to validate whether or not this idea should become a reality. So you'll see a typical product development cycle follows this idea, build, launch, learn pathway. What a design sprint really enables is you can skip the build and launch. It's just idea and learn, and you just get to the learning much, much faster. So for this sprint, we assembled a small team with a really wide variety of expertise. We had an applied data scientist who uses notebooks on a regular basis for client work. From there, we could get an understanding of how our platform notebooks fit into everyday usage with data in Redshift. We included a DSR&D lead. This is a person who was a part of the team that I spoke about earlier that had struggled with collaboration. We knew that she'd really help us ensure that our notebook solution definitely fit this necessity to be able to work in a team. We included an engineering lead, that guy, as our implementation expert. He was there to make sure that our ideas were technically feasible and that our engineering team would be able to support whatever solution that we landed on. We had a designer whose expertise in user experience and prototyping was essential in building that mock-up that we could confidently test on our users at the end of the week. And we included me, the product manager. My job in this sprint was to understand the competitive landscape and also our user personas, and then translate and prioritize the sprint outcomes into engineering work. So by the end of the sprint, we'd learned quite a bit about how data scientists envision using notebooks within the context of our platform. These outcomes really turned into user stories that fit a handful of themes. The most important ones that we found: users would like to work in a familiar environment. Iterating on exploratory work is the way that notebooks are most often used. Our users need to be able to scale up their computing resources, and that collaboration must be possible and hopefully painless. So to dig in a little to each of these themes, throughout our pre-sprint research and our prototype testing, our users made it very clear that Jupyter is a recognizable product. Even users who were not familiar with our platform seemed very comfortable once they jumped in and saw a Jupyter notebook that was a product that they know. So we made the decision to use unforked Jupyter notebooks rather than making major changes to Jupyter or using some other flavor of notebooks. This is because of Jupyter's popularity and familiarity for our users. And we also really like that added bonus that we might be able to contribute back to the Jupyter project if down the road we add some really cool new feature that other people might want. So looking into the iteration and exploration theme, when we dug into why data scientists like notebooks, it's really clear that users have to be able to use R and Python to be able to explore their data and to see some outcomes before writing a more robust production script. While this is already accomplished with local notebooks, using notebooks in our platform adds this element of closeness to data. When you're working with your data in our platform, you can see your data sets right there in Redshift, right next to your notebook. It just feels closer. And so you can also load data into pandas or R data frames with our Python and R API clients. Our users don't want to have to bother with API keys or move data around. What we found was that by hosting notebooks in our platform and giving easy access to their Redshift data, we could give our users a better experience for iteration and exploration than they were already having on their local notebooks. And on the theme of scaling, as data science work gets more and more complex, jobs just take more and more compute power to actually execute. By hosting notebooks in our platform, we can move job execution off of the local machine and into the cloud, which allows a user to just hit go, pack up, take their computer home for the day, and let their jobs just churn up in the cloud all night, rather than sit and wait for the laptop to finish running the job. And our user test really confirmed that utilizing cloud computing resources rather than local resources would make it a lot easier to run more complex jobs. Additionally, we found that giving users the ability to scale up the compute power on their notebooks on demand would add more flexibility for how they really want to work. They'd be able to expand their resources in a way that just was not possible with a local machine. And this is my favorite user story theme, which is collaboration. It's great to work together. In this past, a lot of data scientists worked in a silo. A data scientist might have been the only member of a data team and really not needed to share their work at all, except for with stakeholders or managers or people who aren't really doing the data science. But data is the future, and across industries now, data teams are growing. Data scientists have an increasingly greater need to share their work. So we knew going into this design sprint that our users were interested in using notebooks as part of a team, but that so far this was really difficult to accomplish. When we showed our prototype to existing platform users, they immediately caught on to this idea that they'd be able to use notebooks as a team rather than as individuals. They immediately had all of these great ideas on how they could use their notebooks. They were asking for getting their teammates on board for the testing process. They were building out training documentation, building out reports. They were building out like examples for how to use new features within the platform. It was really cool, and it seemed like the ideas just were popping out of their heads. It was just endless. It was fantastic. So we realized through these user interviews that we needed to make sure that our platform notebooks really included all of these sharing features that already exist for other jobs in our platform. Enabling notebooks with this shared team environment that we already have was going to allow users to jump seamlessly from iterating and exploring their data into delivering insights and sharing insights with their coworkers, and they could do it all from the same tool. It's really cool. So the other thing that users really wanted on the same vein was to be able to operate on the same notebook together or clone a teammate's notebook to branch some work. They wanted to have also a read-only view of the notebook, so anybody can view that current state of a notebook without actually having to run it. It's a way to kind of deliver value without letting somebody touch your stuff. So what's cool is that these outcomes as a whole gave us a pretty good idea of what our end product might include. So now I'm going to turn over the mic to Saranga, who's going to talk about how our engineering team implemented the ideas.
All right, can you guys hear me? All right, how many people are waiting for the analogy? A couple people, great. All right. So we had an ambitious goal, which was to be able to launch Python 3 notebooks in our platform with that read-only preview that Lori was talking about. And for the rest of the talk, I'm going to be talking about our process for implementing this feature, how we built such a large feature into our platform, and some of the technical choices that we made along the way. And what I hope is that this will help you to understand our engineering process, maybe give you some tips that you can take back to your own organizations, and provide some insights into just how hard it is to build something like this and how much work is involved in designing a large feature. So at a high level, there are 3 steps to engineering a feature. First, you want to scope it. So that's figuring out what the requirements are and how much work will be needed to satisfy those requirements. Then you need to actually build it, which compared to these other 2 steps is actually the easy part. And then you want to show it to users and get feedback so you know what to build next. And ideally, you want this loop to be as fast as possible so you can continually incorporate feedback from users into your design. So the notebooks feature that we wanted to build is actually pretty huge. So how do you actually scope a large multi-month project? The answer is that you should never do this. Until you get something in front of users and get feedback, you have no idea what you should build. We use the term MVP, minimum viable product, which means a small but functional version of a large feature. And an MVP is the smallest thing that you can build and show to users and still learn something useful. And if you learn that what you did is completely wrong, that's okay, because you didn't do that much work to build it, and you can change it and build something that users actually want. And it's been empirically shown that large projects are much less successful than a chain of smaller projects that actually do the same thing. So now that I've convinced you to build an MVP, how do you scope that? So this is our process for doing that. So first we start with the requirements that came out of that design sprint. Then we add in non-functional requirements. So these are the things that engineering cares about, but don't describe things that maybe users are doing in the product. So things like security, making sure that it's scalable, reliability, things like that. So once we have all of those requirements in mind, we write out a feature story and user stories. And you can think of these stories like templates for writing out your requirements that force you to enumerate what the goal is and what the business constraints are. So this gets you towards more precise specifications of what your requirements are. Next, we enumerate all the work that's required to satisfy these stories and all of the dependencies for that work. And finally, you want to arrange the work to get feedback as quickly as possible. So this is how our whiteboard looked midway through the process. So the writing on the board has our feature story, and the Post-its are the units of work that are needed to satisfy those stories. And once we're done, we can reorder those Post-its in such a way that we can learn as quickly as possible. So these Post-its describe our entire plan, but our MVP is just going to be a subset of these. Throughout this process, users are going to tell you what they really want, and your plans are going to get disrupted. So all of those Post-its, a lot of them, you may not end up doing. But there's nothing wrong with that. For example, when we did our design sprint, our users didn't express much interest in R in their notebooks because they were much more used to doing things with RStudio and R Markdown. But when our R users saw Python notebooks in platform, they wanted it. And we realized we needed to move our kernel support in Jupyter up on the roadmap. So next I'm going to talk about what we built, and not just the MVP that we built, but the full architecture. So these are the components of our architecture. There's Jupyter, there's a custom-built authentication proxy, which we call the front door. There's containerized notebooks running on Kubernetes, and then there's routing using an open source product called Traffic. And next I'm going to take a technical deep dive into each of these. So an idea that you're going to hear over and over again is security. So we take security very seriously at Civis, and all of our architectural decisions are made with security in mind from the start. Users work with sensitive client data in our platform and in their notebooks, so security is important. And usable security was the focus of my PhD, and I was the engineering lead on this project. So I was interested in making sure that we can make things more secure, but also do this without constraining users. And hopefully you'll see how that plays out in our architectural decisions. So the first component of our architecture is Jupyter. And we chose Jupyter, like Lori said, because it's the clear winner in the notebook ecosystem. This means that users can bring their existing notebooks into our implementation easily and also take them out easily. And one thing that's important is that we used Jupyter without modification. We didn't fork it. And this meant that we were able to upgrade to the latest version of Jupyter the day it was released. So the next component of our architecture is our authentication proxy. So this acts as the front door to your notebook. And the front door ensures that only authorized users can get into the notebook. You can access your notebooks from anywhere as long as you have internet access, but unauthorized users won't be able to get into the front door. And Jupyter does have its own authentication mechanism. You can set a token or a password to get into your notebook, but both of these mechanisms are persistent. And what this means is that no matter how long ago someone got this URL, if your notebook is still running, they can still get into it. So in contrast, our proxy provides time-bound authentication. So when you access your notebook, our platform generates a URL that's only good for 10 seconds and constantly rotates. So when you interact with our notebook through our platform, that rotation is happening automatically in the background. Our proxy also supports multiple users, where each user gets different tokens that identify them. So you can share your running notebook with other users if you want, and they can access it directly. And we don't think this would be a very common occurrence since it's not actually supported by Jupyter. But if you need another pair of eyes on something, sharing a running notebook is the fastest way to do it. And this would have come in really handy for our data science team in the scenario that Lori talked about. They would have been able to iterate on work in their notebook and share it amongst each other. And even though Jupyter doesn't support it, as long as they weren't both trying to do things at the same time, they could have traded work amongst themselves. And with the sharing features that are in our platform, you can also revoke access to a notebook whenever you want. But the unsung benefit of having our own authentication solution is a separation of concerns. Jupyter doesn't need to know anything about our authentication system. And if Jupyter's implementation of authentication changes, it won't break our implementation. And our implementation can actually be more secure than Jupyter because we've broken it out. And we can reuse this authentication proxy to front door other applications. And we've already started doing this internally. So just to clarify, once you've been authorized to access a notebook, we get out of your way. You just have to keep our platform page open in the background to maintain that authorized rotating connection. And then you can open the notebook itself in a new tab, full screen, open a terminal inside of it, and otherwise just interact with it like you would a local notebook. So the next component in our architecture is Kubernetes. So you can think that we have all of these houses that each contain a notebook. And then we have a front door that protects access to those houses. And now we need to put all of these houses somewhere. And that's what Kubernetes does. It organizes all of these houses. So it's kind of like the suburbs. So Kubernetes is an open source system for running and managing containerized applications. We use Kubernetes to run users' notebooks. And Kubernetes has some great abstractions called pods and services for deploying multiple containers. So using pods and services, we can have the notebook and the front door deployed together, and we can specify that the notebook is not accessible to the rest of the world and is only accessible through the front door. And there are two things about Kubernetes that really stood out for us as we used it. First, it just works. If you've ever tried to learn about Kubernetes, you'll know that it's very, very complicated and there's a lot of parts to it. But amazingly, once you learn how to do things, it all just works. We've basically had no problems with any of the core functionality. It also has a pluggable architecture and a decent ecosystem of plugins. There were a few plugins that we needed in order to implement this system. There was just no way to make it work without them. And while they're not as easy to use as the core components, at least they exist, and we were able to make them do what we want. Now, the bad about Kubernetes is actually security. So as I said, we take security very seriously, but Kubernetes' security model doesn't necessarily fit what we need. The issue is that Kubernetes trusts all applications that run on top of it. It wasn't designed around threats from the inside. So if you're using Kubernetes to host your internal services, this is okay, or kind of okay. But for us, the fact that malicious applications can take control of the cluster if they want to, and then possibly steal your data is not okay. So we have a few choices here. We could just not care and let you get hacked, and we're not going to do that. We could lock down what you could do in your notebook, and this is the approach that Jupyter Hub takes. Or we could lock down the system that wraps your notebook to contain the damage if someone does something malicious. So we chose to lock down the surrounding system. So we isolate Kubernetes resources per client, so the node that runs your notebooks will never run another client's notebooks. This way, if someone does run malicious code in your notebook, they can only steal data from their own organization. Even with per client isolation, Kubernetes will still honor requests from internal applications. So we also have to use role-based access control, which is a Kubernetes plugin, to lock down cluster permissions further. So basically now we've got gated communities for each client in our suburbs. Is this analogy working so far? Great. All right, so now we've got all these houses nicely arranged in Kubernetes, but there's so many houses, we need a way to route everyone to the right place. To implement routing, we chose an open source tool called Traffic, which is spelled like that. It's like a GPS for getting to the right house. And Traffic is nice because it integrates well with Kubernetes. When we deploy Notebook, Traffic automatically watches events and creates routes to the notebooks themselves. It's also deployable in a high availability configuration. You can have multiple instances of Traffic running, and they all share the same route table. So if one of them crashes, the rest of them can step in and route you to your notebook. And finally, Jupyter uses a protocol called WebSockets to communicate between the browser and server elements of Jupyter. And many products like Traffic that support proxying don't support WebSockets or don't support it very well. Traffic is one of the few that does. We've tried out a couple others, and we had issues with WebSockets timing out. So those were the components of our architecture. And an obvious question might be, why did we build this ourselves instead of using something like Jupyter Hub, which according to this description does exactly the thing that we want? It's a single system that allows multiple users to create Jupyter notebooks. So I'm going to compare and contrast Civis notebooks with what you get with Jupyter Hub. And I think this is useful because if you're in the market for a multi-user notebook system, you're probably going to look at Jupyter Hub first. And even if you aren't familiar with Jupyter Hub, this comparison should give you a better understanding of what we've built. So this is a high-level diagram of Jupyter Hub. You connect to a single hub server, which spawns notebooks for you to connect to. And that single Jupyter Hub server is a single point of failure. You can spawn lots of notebooks, but there's only one coordinating hub. So that's something that has no redundancy and also doesn't easily scale. Jupyter Hub is also built around a single user design. It doesn't have a way to share notebooks between users or organize them into projects or archive them or clone them, which are all sharing features of our platform that we wanted to support. I also believe that real-time collaboration in notebooks is right around the corner. Literally, it's right around the corner. There's a talk about it tomorrow at 2:05 in McKinley, so you should check that out if you want to know more. And like I said, our architecture already supports routing and authentication of multiple people to the same notebook, while Jupyter Hub does not. And finally, Jupyter Hub doesn't allow for customization. I want to point out that I'm not picking on Jupyter Hub here, even though it seems like I'm really picking on Jupyter Hub. It's a really great piece of software. It just has different benefits to what we want. So Jupyter Hub recommends that the administrator of the server decide what packages are installed and then prevent users from installing their own packages. And they do this for security reasons, and those are good reasons. But we've built a system with a very different security architecture that doesn't have this restriction. We allow you to install whatever packages you need into each notebook. And for those familiar with Docker, we even allow you to bring your own Docker image if you need to customize further. So in summary, our gated community suburb architecture gives you high availability, no single point of failure. Notebooks that are built for sharing and collaboration, so they don't have a single user orientation. And a notebook system that is highly secure, yet flexible enough to allow access by multiple users and allows you to customize the environment that you run your notebook in. Okay, so that was a very long discussion of how we built the system. Now let's get back to the next step in the process where we show what we've built to users and get their feedback. So remember, we're doing this because we want to make sure that we're building the right thing. Once we built an MVP, we started showing our MVP to users. We had a weekly meeting with engineers, product, and design, and internal notebook users that was organized by Lori, where we showed where we were and got feedback about what we should change. And we use continuous delivery at Civis, so everything that we demoed was usable by the people in the room, so they could give feedback during the meeting, or they could go play with the product after the meeting and give us comments later. And to give you some sense of how we walked our way towards a complete notebook feature, here is the general progression of features and how we moved forward. So the first thing that we wanted people to be able to do is create a notebook within our platform. Then we supported people uploading existing notebooks. Then we allowed people to start increasing the RAM and CPU that are allocated to their notebooks. Then we actually put in authentication. So up to this point in the process, we had a dummy front door that just blindly trusted the first person that walked up to it. Once we got to this point and we realized, okay, we're really doing notebooks and we want them to be secure, we put more effort into the authentication. At this point, we also did a design review of the feature as it was at that point and made changes based on that review. Then we started to add new features, like allowing users to change the installed packages and adding support for the R kernel that I talked about earlier. So that's how we built notebooks that are secure, customizable, and collaborative into our platform. Any questions? Thanks. How do we handle versioning? So right now, we don't handle versioning. Notebooks are sort of uploaded and downloaded into our platform, but something that we're working on right now is integration with Git so that you can upload and download your notebooks into a Git repo instead of into our platform, which stores them in S3.
So it doesn't maintain state?
Oh, correct. So the notebook container is completely ephemeral. Mm-hmm. Yes?
Can you go into a little bit how you got the scaling to work for the notebook servers?
How the scaling works in Kubernetes? Or?
Like, because you were saying you could scale the RAM and CPU for your box.
Yes. So right now, we actually just, right now we're at a point where our Kubernetes nodes are a single size. They're all 32 gig machines. And by default, users are given 2 gigs of that via Docker. So Docker allows you to limit the RAM and CPU that's available. And so by default, they're given 2 gigs of RAM. But there is just a drop down right here, a little bit above here, where they can type in the RAM that they want and the amount of CPU units that they want. And so they can scale that all the way up. But another thing that we're working on right now is allowing users to select the instance size that backs their notebook. Sure.
Do you support any kind of a dashboard for that, or so you can monitor all these instances? And sort of second question.
Mm-hmm. Yeah, so we don't currently, so I guess I should say, I don't know if Lori said it, we haven't actually released notebooks yet. The external release target is the end of September. So we don't currently support, once we support selecting the instance that backs your notebook, then we'll have automatic support for GPUs. Yes?
Got 2 questions. So one is I noticed that you have some code here that talking about so
Mm-hmm.
let's say, for example, talking about Redshift cluster,
Mm-hmm.
high that potential for users. And the second question is,
Yeah.
is there any, like, for example, if I use special packages on my notebook environment, is there any way to pre-install those packages for the whole environment?
Yeah, so I can answer both of those questions. So we already support credentials in other parts of our platform. And the way it works is you can actually securely create credentials in our platform. And then if you're creating a script in our platform, you can say, I want this script to have access to these credentials. And they get loaded into the environment that is generated. So the way it would work in notebooks is that those credentials would appear as environment variables that you could then read out of. And the way that we support credentials in notebooks is using asymmetric encryption. So once you create a credential within our platform, the web servers can no longer read it. It has to go off to a more secure computer that can then read those credentials and construct the environment and then give it to you. To answer your second question about packages, right now you could install packages in the environment. You have sudo in the notebook, so you can do whatever you want. But like the answer to the other question, it's an ephemeral container. So it's going to go away when you stop the server or when it times out. But one thing that you can do to pre-install those is you can fork our Docker image and install the packages in that Docker image and then use that Docker image in your notebook. Oh, and sorry, I didn't answer your question about the monitoring. That's also something that we're working on right now. We have internal monitoring of all of those resources, and we're working on exposing them to users. Any other questions?
If you have any more questions, please come talk to us. We have a booth out in the hallway, and we'll be around tomorrow as well.
Yep. All right, thanks.